Myth number 2. MEV lets miners manipulate transactions. Expanding on our first myth, it's important to better understand how MEV or miner extractable value works. There's a lot of fear-mongering suggesting that MEV means that these blockchain miners are dangerous, manipulative middlemen who are going to be able to modify our transactions at will, and that simply isn't the case. The uninformed rhetoric around this stems from a type of attack that we call a sandwich attack that miners are capable of performing when processing a poorly constructed transaction. To understand how that takes place and the limitations of the MEV attack, we have to first understand an overview of how blockchain transactions take place. When we're creating a transaction on the blockchain, all we're doing is writing out a set of instructions for that system to carry out. Like any computer system, this is going to have its pros and cons because the computer will do what we tell it to do and only what we tell it to do, regardless of that outcome being good or bad. We sign a transaction with our private key, making it tamper-proof. And then we broadcast that to the network for miners to process the transaction, which they ultimately do by changing the state in the blockchain's underlying records. And there it'll sit in that public record. You can think of this process a bit like writing a letter and sealing it with a wax seal. Inside of that letter are a set of instructions you want your bank to carry out. The miners are ultimately like a postal service carrying that letter to the bank. But it does get a bit more complicated than that. Once you've signed that letter, it sits in a pile of other letters, and this is a place that we call the mem pool or memory pool. It's where transactions sit while they're waiting to be processed. What's unique about the mempool is it is public, and so anyone can see the transactions that are waiting there, the contents of that transaction, and how much gas is being bid to execute the transaction. Miners are also not just one unified entity. They're actually thousands of different users and hundreds of different collectives of miners. And you can think of this like different shipping companies. Now, people may claim that a miner can censor your transaction from the blockchain, and that's not true. Just like UPS can't unilaterally decide to censor you from being able to send any type of mail with any provider. However, UPS does have the right to decide that the mail you're trying to send is something they don't want to ship, or that the price you're willing to pay isn't good enough, and so you're going to have to go with another provider. That's fair, and it's well within their rights. Once you manage to select a shipping company, though, and get your transaction taken, the process is the same. The letter gets sent, and the actions in the letter get taken. Now, where this becomes a challenge is in the sandwich attack that we mentioned earlier. And that's when an individual miner decides to read your letter and front run that action. Imagine you were sending a letter to the bank that says, I want to buy $1 million worth of gold at the current price, regardless of what that price is. Any mail carrier that read that would realize that since you aren't putting in a set price, and because your purchase is so large, if they bought a bit of gold at the current price before your instructions arrived, then you'd be buying it off them at a higher price. This means your transaction would go through, and they would still make a profit. This is part of the trade-off in a public decentralized system. When things are on a public ledger, we have to change our behaviors. Now, in this case, your instructions didn't change. In fact, your instructions were executed exactly the way you wrote them. The problem is you gave bad instructions. If you said, I want to buy $1 million of gold at the current price of X and not any higher, then the transaction wouldn't have been front-run because it wouldn't have been profitable to do so. If you sent 100 separate letters saying I want to buy $10,000 worth of gold at the current price, regardless of what that price is, then none of the individual transactions would have seemed large enough to front-run. But you put through a single large order all at once, regardless of the price, into a public mempool, and that's what created the issue. Now, this isn't something new. It actually exists in our current financial system, and is called high-frequency trading. When you send a transaction to your bank asking them to purchase a certain stock on the stock market for you, they have to relay that transaction to the stock market. The relay of that transaction is something that can sometimes be seen by other trading firms. When they are attempting to make a purchase of that stock, they instead purchase the stock fractions of a second before you and turn around and sell you that stock at a slightly higher price. Now, while this action is manipulative and predatory, it certainly doesn't make them financial intermediaries, nor does it let them change the transaction you sent. That transaction still went through exactly as you issued it. These manipulations are instead a lack of user education and not adapting our behavior to a new type of system with public visibility. To recap, even though in an MEV sandwich attack, my transaction takes place exactly the way I told the system to do it, it cannot be changed or edited, it cannot be modified, and it cannot be censored. If one service provider denies me because my payment was too low or because they wanted to take another action instead, another will pick it up. It is an open bid marketplace. The only thing that changes is the outside market conditions, not my transaction. I am the only person to have sovereignty over the contents of my transaction instructions. The exploit instead takes place because of how I formed my transactions. This is something that can be fixed and avoided with better user education, clear indicators on front ends that highlight risk, and using MEV-proof systems such as ArcherDAO, Alchemist Mystex, or CowSwap. Ultimately, it's possible to send tens of thousands of transactions with tens of millions of dollars in trades and never have a single loss due to MEV manipulation. Ultimately, MEV does exist, but the technology itself is not specifically good or bad. And while it can create competitive race conditions, miners cannot ever change your transaction. They can only take advantage of poorly formed transactions, methods, and approaches by executing their instructions quicker and changing the environment. MEV does not create a new problem. It highlights one that already exists: users making bad transactions. That's not a technology problem. That's an education problem. And it's something that we as an industry need to fix. But it still makes this myth untrue. For the text version of this myth busting, or to see it in other languages, visit cehv.com/myths.